VCE Chemistry, Unit 4, Volumetric Analysis, Technique. In this session, we'll focus on the techniques of volumetric analysis in terms of its experimental procedure, and we'll focus on the direct acid-base titration that we have learned in Unit 2. Technique Part 1, Making Standard Solution. By the end of this session, you should at least be able to distinguish between these key terms: primary standard, standard solution, and secondary standard. Okay. Primary standard, we're normally talking about solids. They are substances that are so pure that the amount of the substance in moles can be accurately calculated. There are a set of criteria they must meet. For example, they need to be readily available in a pure form. They need to have a known formula so that we will be able to obtain the molar mass of that substance and calculate the moles. And they need to be easy to store without deteriorating or reacting with the atmosphere. Preferably, they should have a high molar mass so as to minimize the effect of error in weighing. And also, preferably, they're inexpensive. Commonly used primary solids, primary standard for bases, we use anhydrous sodium carbonate. The sodium carbonate, it looks like it's a salt, but it's actually a weak base due to the hydrolysis of carbonate anions in water. Okay? And we also use sodium borate as a weak base. Both of these bases are weak bases. Acids, we use hydrated oxalic acid, or what we call PHK, which is essentially potassium hydrogen phthalate. Okay? So this hydrogen can be donated. So both acids are actually organic acids, and they are weak acids as well. And secondary standards. Secondary standards exist because people ask, why don't we use strong acid and base as primary standards? Because normally strong acid and base, they actually produce a sharp titration curve, which is easier for us to determine the endpoint. However, the concentrations of those commercially supplied strong acids cannot be accurately specified. They normally count in a solution, and the concentration is about. And the strong bases such as KOH and NaOH, they're solids, but they absorb water and react with carbon dioxide in the air. As we said, that primary standards cannot react with the air easily. There are also many other hydrated salts we could use, however, they lose water to the atmosphere. Therefore, their formula changes constantly, and it makes it hard for us to actually determine it. However, that doesn't mean that we can't use them as standard solutions. What we need to do is that we need to make them into solutions and standardize them before the actual titration happens, right before. And for that reason, we call them secondary standard. Now, making standard solution. The overall procedure is basically dissolving accurately measured mass of a primary standard in a accurately measured volume of water. That's how we make all solutions. The key is that it needs to be accurately measured. Okay? So we use volumetric flask for this particular task, and we do not use measuring cylinder to measure that volume of water, because measuring cylinder simply is not accurate enough. Okay? So volumetric flask, does it need to be cleaned? Of course, it has to be clean. However, does volumetric flask need to be dried before we use it? No, we don't. Because once we have added the primary standard, we will have to add water to dissolve the primary standard anyway. So it needs to be clean, but doesn't have to be dry. Now, making standard solution. First of all, we need to weigh the primary standard in a digital balance. Then the weight sample is poured into the flask. Then we need to wash the beaker for any residue. And the washed liquid is also added to the volumetric flask. Okay? The flask is half filled and we add water all the way to the bottom of its neck. From that point onwards, water is pipetted. Pay attention, it's not just added, it's pipetted to the graduation line so as to make sure that you do not go over. Once you have done that, then the entire volumetric flask is inverted to make sure that everything is mixed thoroughly. And then you leave it there. Okay? The equipment needed for this part of the procedure includes digital balances, so as to measure the mass of a primary standard, and a volumetric flask, so as to prepare our standard solution. We also use other equipment, includes like funnel, beakers, and drop-in pipette and measuring tray. However, the one thing that you think we will use when we work with solutions, that is measuring cylinder, we do not use it to make standard solutions. Okay? These are the volumetric flasks that we're talking about. Each flask can only basically hold a set volume of solutions. So therefore you have different sizes.